Okay, so let's keep moving forward here. Now we're going to jump to our second part here, which we will be talking about inheritance. Inheritance is one of the key components, key ingredients of object-oriented programming. Okay? Inheritance is the ability to be able to extend, enhance, modify an existing class. With what we're going to be talking about, I'll be describing what inheritance is. By using inheritance, we're going to be able to extend classes. We're going to be talking about the protected access modifier. We have seen it before, but today, by knowing about inheritance, we're going to know how to apply protected keywords a little bit better. What is its use? Why we use it? We'll also be able to redefine, to modify the behavior of methods, of properties. Okay? We're going to talk a little bit about object class. What is the object class? Okay, why it's important, why inheritance is important. As I said, it's one of the main features of object-oriented programming. Programming with objects. Objects that belongs to a class. This class may not be alone in the universe. It may have come from another class, which came from another class, which came from another class. Do you know that any class that you create in C#, even though you may not explicitly say that it inherits from another class, but they all inherit from at least one class. The one? It's a class that is inside the system. We're gonna look at that. Objects. Object is a class that's it's the base class of every single class. Okay? We're gonna look at that. What we're gonna be talking about is available on chapter 10 of the book. Okay? Again, if you have the book, I highly recommend that you explore the exercise at the end of each chapter. They are they have various degrees of complexity. So again, it's a good place to have a look if you are a more advanced, if you have more knowledge about the subject already. Okay, so what does come to mind when you hear the word inheritance? Anyone? Inherit properties. Their assets. Yep. What else? What else comes to mind when you hear the word inheritance? Anything else?
We inherit the assets, but not the information.
Okay. Okay. What is that? Reusability. Okay, inheritance in general, it doesn't need to be applicable only to coding. Inheritance in general, I mean, if you hear the word inheritance out in the wild, it might be talking about what? Money. Cash. It might be talking about what else? Genetics. Okay? So, money. I know that for a fact. Genetics, yes, that's correct. And again, very similar to what we're going to be seeing here with inheritance. One class will be inherited from another one. The properties, the cash from that other class. Cultural inheritance as well. Someone mentioned that, something related to that. So basically inheritance, when it comes to coding, is the ability for a class to apply knowledge, data, information from a more general class to a more specific class. We saw this diagram the first time that we spoke about UML. We saw this little diagram that had a person and it had the student and professor. Okay, here's an example of how we can demonstrate the diagram, a inheritance diagram. Okay, we have person class, we have student and professor. They both inherit from person. Okay? We have common elements at the person level, and then we have specific information about each class on its own class. Okay, I would like to ask for just to pay attention a little bit here. If you need a break or another break, I mean, you can go for it. You can talk how many times you want outside, but here, if we are talking about the subject, let's try to pay attention. Again, the doors are open. You can all leave, I mean, anytime that you want, you can have your break there at any point in time. But if you are here, let's pay attention. We have plenty of breaks, plenty of exercise to have the opportunity to talk amongst each other. But again, because I need to keep raising my voice and I'm going to lose my voice. Okay? So that's part of the respect that I mentioned in the first class. Respect is about, again, listening the time that we have to stay here. Okay. So, person and students. So, what is the use of inheritance? Why? What are the advantages of inheritance? It saves time. Let's look at this. Why is it saving time for us? What is it? Why that would save time? You don't need to write the code again for the elements that we have in common here. I mean, nothing wrong from a technical standpoint to repeat all this information here and here. There's nothing wrong there. However, one of the key aspects of coding is not duplication, not having duplication, isn't it? So again, by doing that, we avoid duplication of code, okay? What else? We have reduced chance of errors. Why does it reduce chance of errors? Yeah, because if we have less code, we have less opportunities to make mistakes there. Okay?
Easy to find the error.
Is it?
Easy to find the error.
It's easier, yeah. Because again, instead of having code all over again and again, we have code in one single place, and that's it. As coders, as programmers, again, I don't know who will be coding here for a living, who will not. But guess how much time do you spend on average? I mean, there's no hard facts here. But there's a saying that, actually, let me throw this back to you. How much time do you think that you spend creating new code? Like a developer, how much time does he or she spends creating new code, developing new stuff? Not much, about 20% of time. The other 80%, what we are doing? Fixing our own code, troubleshooting our own code, not only our code, but somebody else's code as well. So again, and why am I saying that? Is because if you have less code to manage, if you have a code that is cleaner, clear to manage, your job will become easier. And again, inheritance will help on that. Will help to make your code, to make less code, to make code cleaner and clear. Okay? Makes program easier to write. It does. This video here, it's active on the PDF that I have uploaded to Centennial. This is the same one as the bonus, okay? The bonus, who had a look at the bonus? Yeah, so it's the same video there. I'm not going to play it again. There are some other videos here that we're going to have a look. Okay, let's talk a little bit about terminology. Terminology, we have parent class and we have subclasses. Okay? So, parent class, it's called what? It can be called as what as well? Superclass, parent class, base class. Base class, sometimes I get confused. Base class, sometimes I think that it's the one at the bottom. But it's not. It's actually the one at the top. Okay? So that's a base class. Let's talk a little bit about the next one. So we have, again, you're going to see those different terminologies. Okay? And then we have child classes. We have derived classes. Again, you may read, you may hear all those different types of terminologies. Derived class, extended class. It's a class that is extending another one. Subclass, child class. Okay? We're going to see the expression is a or is an. A car is a vehicle. A truck is a vehicle. A sports car is a car. So, to see if a class is a parent or a child of another one, you should be able to use this expression, is a or is an. Okay? Okay, ancestors. So it's not just, we're not just talking about two levels here. It's not just child and parents and that's it. We can have multiple levels of inheritance here. We can have the parents of the parents of the parents of the parents. But who is the ultimate parent of all classes? Again, object. Object is in the top of the food chain in terms of classes. Okay? So, all of those ancestors, the class at the bottom, it inherits all properties, methods, fields from all classes that came prior to it. Okay? All of them. And the fact that it inherits from everybody on top of it, it's called transitive. So it's not just from one class to the immediate class, but to every other class on top of that. So this is called a transitive behavior. It accumulates the properties, the methods. If I would ask, most likely, which class has more methods? Is that a child class or is that a parent class?
Child class, because the child has different properties.
It's a child because it has not only the methods of the parents, but its own methods too. Okay? Yes? Enums? No, you don't inherit enums. Enums are not objects. Enums are not classes. The only thing that you can inherit from is from another class. Okay?
So we have an enum in one class and then we inherit a class and we get enums around them.
You're gonna get, yes. You're gonna get any enums that might be defined in that class. Yeah. Okay?
Can we have two classes, one class inheriting from two classes?
Actually, so this is called multiple inheritance. And C# doesn't implement that well. It's not, I would say that well. It cannot. So the short answer is it cannot inherit from multiple classes. However, there is a workaround that on C#. We have, who knows what's the workaround?
One class which inherits the second is also inherited. I mean, we inherit that class.
True, but the workaround to inheriting multiple classes in C# is interfaces. Because it can have, it's the same thing, isn't it? Because it can inherit from multiple interfaces. Okay? So that's about it. Okay. Here is a code example. Let's have a look at this. Okay. Demo employees, yeah. So we have it right here. So here, we have, in one single file, we have 3 classes. This is not my preferred way of implementing multiple classes. We usually have in different files, okay? When you guys are done, I mean, just let me know, okay? I said for the second time, the doors are open. You guys can just leave if you want. But I cannot be talking at the same time that you guys are. Okay, so we have in one single file, 3 classes. Now, the ideal scenario is really to break that down into multiple files. I would prefer that, okay? But this is an example that comes straight from the book, so let's leave it like that, okay? But demo employees is the main one. So this is the application. Now we have employee class, which apparently doesn't inherit from anyone, but it does. It inherits from object, even though there is nothing here, no definition of inheritance, but it does inherit from objects, okay? Now we have commission employee, and this is the syntax. When you want to make a class, inherit from another one, okay? So, let's look at that. Employee, we have what? We have a private fields, a public property, and auto property here actually. We have a public property called salary, a private one called salary as well. So if you declare an object of the type commission employee, like here, salesperson, I can call the properties of the parents. No problem here. You see? ID num, even though this is a commission employee. Okay? Let's see. Yeah.
You instantiate an object from the child.
If you want the child, you instantiate the type. You may want to create an object from the parent as well. That's fine. All of them. So we're gonna see. So if I go. So again, you see all of them together. Okay? Okay. Now, of course, it only makes sense to have a child if you are doing something else there, something more there. There's no point of having a class like this because it's not doing anything differently from the parents. Okay? So again, we are either adding more properties, adding more fields, adding more methods, or we are changing them. We might be changing them as well. For now, we are just adding. We are creating another class, inherited from employee, and we are adding a new property called commission rates. Okay? Yes?
To inherit, does the class have to be public or is it okay if it's internal?
The class, it's okay to be internal. Internal only means that this class is only used in this project. That's really it. Okay? So internal classes, I mean, this could be internal and we can still inherit from it. There's a way that you can block a class from being inheritable. There's a keyword that you can use called sealed. And if you seal a class, it cannot be inherited from another class. But we're going to mention that a little bit, maybe in the near future. But for now, we are just dealing with classes that can be inherited, from each other. Okay? Let's see here. Okay, so this is an example that I just went through. Let's have a look at this video here. This is from the book Author.
Inheritance is the act of creating a class by basing it on or extending an existing class. When you create a new class by extending an existing class, you can call the two classes the base class and its derived class. Programmers also say that the original class is the parent class and the extended class is the child class. Or you can use the terms superclass and subclass. Let's take a look at a party class that you might create to hold data about parties you might throw. You might decide that every party should have fields for the month, the day, and the start hour for the party, and also perhaps the number of guests invited to the party. You might create properties for each of these fields, and you might have any number of methods, including perhaps an invite method that displays data about the party that you can send to your friends to tell them when to come. Suppose you also create a dinner party class, and you decide that a dinner party needs a month, a day, a start hour, and a number of guests, and an entree that will be served to tell them when to come.
Let me just step back here for a second. Look at this example here. We have a set of private fields at the top, and a set of properties, public properties. So we have month, and it's too small, but trust me, that's what we have here. Private fields and public properties, but they are auto-implemented properties. So, do you see anything there that does not make too much sense? That kind of looks, what's the point of something there? There's something there that there's not much point of being in that example. What does not make too much sense there? Why? Implemented. Yeah, that's it. So the set of private fields here, there's no point for them because the properties are not reading nor writing to them. They are all auto-implemented properties. So there's no connection between this month here and the month here. No connection. So these private fields here, they could be eliminated and it would not make any difference for this code. Okay? Just wanted to make a note about that. Again, technically speaking, it's okay, but there is no practical use to have those private fields here. Does it make sense? I mean, anybody didn't get that? Not clear? Okay. So when you have a get and a set, usually I say use private fields. Don't use the auto-implemented. Here we have auto-implemented. Auto-implemented properties, they don't need private fields. They don't read and write from these. They have their internal private field, but it's not accessible. So it's not reading from here nor writing to here.
It's like you're declaring month variable with a capital M, basically.
Well, we are declaring capital M right here, month. But the get is not getting from here. The set is not setting from here. There's no link between them. So, again, right now, there's no use for them. Just why it's? Because you see the set, it's auto-implemented. You can create auto-implemented properties like this. There's no clear fields that we're going to be writing and reading to. But behind the scenes, C# makes a private field available. We cannot have access, but there is something working behind the scenes. However, here, because it's not getting from the month, it's not setting to the month, this doesn't make any sense to have this block here. Okay?
So in this case, it's the opposite. You must have all the fields is not necessary. You can remove.
Yeah, you could in this example here, if you want to keep auto properties, we don't need private fields.
But it's the opposite, right? Because I would think why you need to have the properties, because also if you don't have properties, there is no way to access the fields, right?
Correct. But in this case,
no way at all, right?
yeah, because yes, correct. There is no use for them. Anyway, I just wanted to mention that. Let's get back here to the explanation.
You can send your friends to tell them when to come. Suppose you also create a dinner party class, and you decide that a dinner party needs a month, a day, a start hour, and a number of guests, and an entree that will be served. And a dinner party needs properties for month, day, start hour, and number of guests, also for the entree. And a dinner party needs an invite method. If you compare the party class and the dinner party class, you'll see that much of the work to create the dinner party class had already been done for party. Party already had declared a month, a day, a start hour, and a number of guests. Properties had already been written for those 4 fields, and the invite method had already been created. Therefore, it makes much more sense for the dinner party class to inherit from party and take all the already written fields and properties and methods from its parent and only declare the new things that are needed for a dinner party, the entree and its property. This makes much less code writing necessary to create the dinner party class. When you declare a dinner party object, you use the month and the day and the start hour and the number of guests from the parent class, and you use the entree from the child class. When you use the invite method, you can use the parent class version, and you can correctly display data about the dinner party. Inheritance makes your job much easier.
That's about it. So again, just another example of inheritance. We have gone through this. Again, so far, it's okay. But it will get more complicated, don't worry. I mean, it's not that easy. Okay? So let's have a look at this quick Nearpod here with 4 questions. Just to recap, remind, give you a chance to write some notes there. Let's have a look at this one. So Nearpods, go have a look there. Here's the codes. And let me close this. Here's the code. Give it a try. Simple questions. Just to do a bit of a recap. Okay, so let's have a look here. So specific types of objects assume features of more general classes through inheritance. Now, polymorphism, we're going to be talking about polymorphism in the next class, I think. If not, soon enough. Encapsulation. Encapsulation is what we do when we declare private fields and public properties. We are encapsulating the data inside our object. We are not exposing them. Okay? Structure, we saw a structure before. It's very similar to classes, but it's a value type. Classes are reference types. So we are talking about inheritance here. Okay, let's see what is applicable. Actually, what is not one of the benefits of using inheritance? It's T. So it reduces chance of errors. Yes, it does. It makes it easier for anyone that is already familiar with the parent class just to get used to the child class. It saves time. But computer, it does not save any memory there. Actually, as I mentioned before, if we ask which one occupies more memory, is that the parent or the child? An object of the parent or an object of the child? Well, which one do you think would occupy more memory in the RAM? The child, because the child is supposed to be bigger, have more methods, more properties. So the last one does not make sense. Okay, a child class is also called a extended class. So base class is the parent, superclass is the parent, delineated class, I have no idea. I don't. Okay, so assuming that the following classes are well named, that the names, they make sense, which of the following is a parent class of a house? Apartments. So apartment you can think of as what? From about apartment and house. They're kind of a siblings. Yeah. Same level there. Victorian house. It will be a child. A good candidate to be a child. It's a specific type of house. Building. Yeah. More general type of building. And my house will be maybe an object. Okay, so building. See? Very easy. Subject is, could not be easier than that. Well, let's see. So, let's enjoy while it's easy. To celebrate that, let's go to that exercise. You do it, 01. So, the exercises are under week 5. Now, some of the feedback that I got, I'm trying to act on that feedback. So some students said that I didn't provide enough exercises. So I said, okay, so I'm going to go overboard now. So, plenty of exercise there. You do it 1, 2, and 3. They are step-by-step exercises that I've taken from the book. It will tell you exactly what you're going to be doing. So again, very, very easy to get through, to get you familiarized with what we're covering here. And then we have some a little bit more involving here under programming exercise 05. You're not ready for that. So we're going to start with 01 there. I'm going to open just to give you some initial instructions there. So if you have a look, it starts with this number 1, 2, 3, 4. This is just a brief overview. Don't stop and don't act on them yet. Start from the point after that, okay? Because here, this is just a brief overview. After that, you're going to see step by step on what you need to do there. Some of the exercises in the book, they use quite a lot auto-implemented properties like these, okay? That's fine. That's fine. If the exercise is asking you to use that, just use that. That's okay. What else? That's it. So let's get this going. Again, it will walk you through step by step on how to create two classes, inherit one from the other one, We're going to take a few minutes here, and then we're going to move forward with some not so simple concepts, but again, this will help us build our knowledge there. So I see a question there. Will you post all the code that has been worked on today on Centennial? Okay, so the codes that is around the exercises, they will be posted tomorrow. All the code for the exercises. This code that I'm demonstrating here, I can post there. They are just not super organized, but I can post there. If you mean the code that I'm explaining here, the examples. Actually, I can do that right away. So again, get started exercise. I'll just start to put together this code here to upload. Okay. Okay, so again, the exercise, I'll post the code tomorrow. This code that I'm going through, that I'm demonstrating, I'm going to post right away. And it will be called code in figures, which is this code here. So I just added there. If that's the code that I'm walking through during my presentation here. Again, if you need a break, that's the right time as well. Just go for it. Yes.
If we're struggling in one exercise, how we can send like a question for you? Like
You can send via email, but the thing is that via email the code usually gets blocked, so you can upload the codes to Slack. No Slack? So you can upload the code to Slack, you can upload directly to me, and send me a note. Or on Slack you can say, @Ederson, and then I get an email.
you get it.
Yes, okay? That's the best, that's one of the reasons why
Upload the solution file, everything.
the code, whatever you want to upload there, and then just let me know. Okay? And then I can have a look. I do that quite a lot. I have not been doing this here in this class, in this semester. No, we didn't get used to it. But other semesters, I ask the students all the time to upload it there, let me know, and I will review the codes. I have a look at the codes.
Enumeration, that took me like 10 years to figure out that you cannot
Yep.
separate the word.
So again, you can upload there, or if it's just a question without codes, you can just email. Okay?
What does protected do again?
Protected, it makes the member, in this case here, this field, available to the class and to the children. So in the children, you can call this fields, but not outside the class. Not outside. Yeah. So it sits in between the private and public. It's not as private, but it's not as public either.
think I'm not sure if I'm reading this right, but it's saying that car loans can have no more than 3 digits. So, couldn't the car loan number be like 999?
Not have more than 3 digits? Okay.
Since it says have.
Okay. Although loan amounts might have larger loan numbers, car loans will have loan numbers that are no more than 3 digits. If a larger loan number is provided, the program will use only the last 3 digits for the loan. Okay, so with that in mind, what are you thinking of doing? What's your thought process?
Well, it's just that, so, because 999 is a 3-digit
Yep.
loan number, but our thing here is 100. I'm trying to understand why it's checking to see if it's lower than.
If the value is lower.
Yeah.
Okay, so that's for the loan number. So.
Because if it had 2, if it had 2 digits.
It will be lower.
Yeah.
So lowest invalid number here. Let's go all the way up. Let's see what it's declared on the lowest one. So what is that? Oh, lowest. What is that lowest value number that is being displayed here?
It's 100.
Okay, 100.
Yeah.
Okay.
So if I had 99 as my loan number, that would get rejected?
It's not that it would get rejected. It's gonna be, let me see. So lowest invalid number.
So that happens. So then it would just take the base number. Yeah, I don't really know what it's doing here with base loan number.
Base loan number, it's accessing the loan number from the parent. So base is a keyword, and we're going to be exploring that in a second. Base goes to the parents to access the value from the parents to avoid confusion with this loan number. See, because loan number has been redefined. To be honest, I have gone through this exercise in a while. So,
because it's like confusing, because I haven't said anything for the parent class, right?
Okay.
Whenever I'm first declaring.
So you have loan here for the parent class. Okay, loan. Okay, so that's for the loan number. Sorry. Where is this definition here? Is this the one?
It's right. Yeah, I haven't finished writing it.
Okay, got it. But that's the one. Okay, so loan number here. Let's scroll up. Loan number, yes, you define it here. You're defining it here.
Right.
But you are just.
But it doesn't.
The get. Now, again, the rule here might be confusing, and maybe there is something wrong with the exercise. The point is that I have solved this exercise before, but again, 2 semesters ago, so it's not very fresh in my mind, this particular exercise.
It's just like I'm thinking whenever you go to set the loan number, right? And you put in 99, for example, it's gonna start doing all this stuff, and it's saying like the base loan number is equal to value or something like that. But
because here's the thing. Again, I'll just forget for a second this rule here, because this might be confusing here. But what this is doing is just saying that use the loan number property of the parents. And what is the loan number of the parent is doing? It's applying this here.
I think I might understand. Maybe if that was 1,000. Okay, if that's 1,000 instead of 100, now it's saying if the value is less than 1,000, then that means that it's 3 digits, so then it gets set to the baseline number. Otherwise, you take the remainder. Okay, that makes sense.
So you understood better. Again, I don't remember the details, but the point is that the loan number will call the top one. Okay, but I guess that's indirectly I give you the answer.
Yeah. It was because I put 100 there, and it was supposed to be 1,000.
Or is that supposed to be 1,000?
It was supposed to be 1,000.
Oh,
instead of
got
100
it,
because-
got it.
Yeah, now it's saying if the value is less than 1,000, that means it's 3 digits. Go ahead and set it. If it's if it's 1,000 or higher, we need to take the remainder.
The remainder.
That
So
makes
it becomes like if it's 1,100, it becomes 100.
Yeah.
Isn't it? Because it's just the remainder when you divide, isn't it?
Yeah, it's just the remainder whenever you divide. Yeah. Okay.
Awesome. Glad to help. Okay. So let's go to our last stretch here. Let's go to our last stretch. How are things moving there? All good? Yes.
There is a statement like return base dot
Base. We're gonna talk about. Is that exercise 1 or 2? 2. So we're gonna talk about that right now. What that base is. Okay. Great. So again, keep those exercises. Keep them going. After this class, you don't have a bonus this time around, but you're gonna use this time to practice those exercises. Now you have plenty of exercise to go through. Not only that, you're gonna have the solution, you're gonna have the videos, you're gonna have everything available to you. And again, practice them. We're gonna go to our last segment, which I'm gonna go in more details about inheritance. We're gonna see what base means and what some other things mean as well. Let's see here. Okay, so we have discussed about protected a little bit. Protected means that it's accessible inside the class and to the children as well. Okay, here's an example. We have the same class employee. Let me see here, demo 2. Okay, so here we have, look at this. See, we have the class employee and we have the commission employee. Now, instead of making salary protected, it's set to, instead of making salary private, it's set to protected. It means that now we can access salary from the children. But why would we do that? Well, here's the thing. For a commission employee, according to our little system here, commission employee does not receive a fixed salary. It's a commissioned salary. So, if the employee, if we provide a percentage for the commission of the employee, the salary becomes 0. And now we can access the salary because now it is protected. If we change this to private, here's what we have. We have a problem there. It cannot access. Salary is inaccessible due to its protection level. Okay? So again, now that it's protected, the children can access that. Okay, so that's it. Protected for that is to allow the children to access that member as well.
So in the same class.
In the child class.
Yeah, in the child.
So protected can be accessed inside the class and inside the children, the child of that class.
The private's only in that class.
In the class itself, yes. Correct. Yes.
projects and inherit classes from them?
Yes, you can. You can, as long as you define the namespace, you call that namespace, you can access any class from that namespace, even if it's from another project. Another solution, yeah. Now, again, you have to make a reference here. And remember what we did with JSON today? We added a reference. If we are accessing a different project, we have to add a reference as well. We're going to do that once we get a little bit later in the course talking about testing, okay? Okay, so that's protected. Protected. Again, here and there we have discussed protected. Any questions about protected? Again, that's really it, okay? Commissioning, again, this is the example of the salary. Just the same example. Now, here's the thing. This example, the employee and commission employee, we are adding a new field and a new property to our commission employee. However, inheritance is not just about adding more stuff. It's not just about adding more methods or adding more properties. It can be changing behavior. It can be that the parent behaves in a way and the child needs to behave in a different way. And that's what we're going to have a look now when it talks about overriding the base class members. Overriding means that we are changing its behavior. Okay? Let's see if we have an example here. We do. Let's see this example. Students. Okay, in this example, we have two classes here. We have students and we have scholarship students. The difference between them is that scholarship students, they don't pay tuition, okay? But the student does. So, in the students, we have a rate, a constant rate of $55, and we have a public property called credits. And what credits is doing when we set the value of credits, we are calculating the tuition. Tuition is equals to number of credits times rate. We find the final tuition, okay? However, a scholarship student doesn't have tuition. Tuition is 0. So, a scholarship student has credits, but tuition is 0. So we need to change the behavior of the child. We have to go to scholarship students and we need to recreate or redefine credits so that whenever we assign a value to credits, tuition becomes 0. We don't multiply them. We don't allow this to happen. We override the property. Now, to be able to override the child, we're going to set in the parents the keyword virtual. So, we have this combination. Virtual in the parents, override in the child. Again, very good to make a note about that. Okay? Very good one to be one of a little question there in a quiz. Okay? Again, good combination there. So if you, and by the way, just because you have the virtual keyword, it doesn't mean that the child has to override it. It does not have. It's just the parents say, it's okay to override me. It's okay to redefine me. My children, it's okay if you override my property. Just that. Okay? In this case. It can be, again, applied to properties, applied to methods. Okay?
So this is good to use in a special case, right?
Yes. In a case that you want to allow the children to make change to that method.
To change the superclass.
Yes, to change the behavior of that method or that property. When I say behavior, I mean I'm talking about the codes. Change the codes. Change how the codes will behave. You want to keep credits, but you don't want it to behave the same way as the parents. You want to make change to it. Now, if you look at this, we just did that for the sets. Get remains the same because we didn't touch get. Okay? We only touched set here. We could have changed get as well. We just didn't want to. We don't want to make any changes to get, just to set. Okay? So again, virtual in the parent overrides in the child. Yes?
For instance, we have a static property,
Okay.
and if we make change in the base code in the child class, in the property, because it is static, does it reflect in the parent class too?
No changes that you do in the child will reflect back in the parents.
Even though it's static.
No, it's like the parents. The parent is not aware of the child. I mean, whatever happens in the child, it happens there. It's in a way, it's independent from the parents. The parents doesn't change its own behavior because of the child. Okay? Now, the child can redefine like this. And again, regardless if this is a static or non-static, it doesn't matter. It will behave the same way. Okay? Here, this is not a static property. It's a non-static one. You don't have the keyword static here.
So in this case, should be not the same, but almost the same. If I put like a if I put over there on the set if.
Here?
Yes.
Well, again, different ways to solve that. Maybe we could have another field that would say student type. And then you could say, if student type is regular students, calculate the tuition like that. If student type is equals to scholarship students, set tuition to 0. Again, there are different ways to solve the same problem, the same situation. This is one. You can use inheritance. Okay? We're going to see many examples of inheritance. You may come across overrides in virtual being used before the access modifier. It's the same thing. There's no difference. So it can come before or after, but it's more common to have the overrides in the virtual after the access modifier. Again, virtual could be before as well. But again, virtual does not impose that you have to change. No, the children doesn't have to. If the children wants to use it as is, they can. It's just the parents just saying that it's okay to change me. Okay. Okay, so we're going to get to new in a second. That's the next step here. So as you can see, we are starting to become a little bit more complicated here. New is another one. New is another situation there. Any questions about virtual overrides? Okay, so let's move here to new. Okay, you can read that on your own time. This is the example there for the student and the scholarship students. Okay, now we have also a keyword called new. New. Let's open this demonstration here. It's commission employee 2. Yes. Okay. So commission employee. We have seen this example before. We have this method called getGreeting. This is implemented in the parents employee. So we have get greeting here. You see, there's no virtual there. There's nothing, just a regular method, okay? However, even though this is a regular method, I can, and I'm not going to use the term override here, but I can redefine this method in the children by using the keyword new. Again, new can be before or after the access modifier, okay? So, as I said, even though there's no virtual here, I can still say, I can still redefine by using the keyword new. What would be the question to ask? What is the difference, isn't it? Actually, they are pretty much the same. The difference is very minor, very subtle. I'm not going to explain today, but there is a little difference. Okay? I'm going to explain this in the next class with an example. But again, I don't want to do it right now. I just want you to keep this in mind. You can redefine the method by using the keyword new. If I don't use new, look what happens here. Visual Studio gives us a warning. It's not an error. It's just a warning that says, hey, do you know that the parent has already a method with the same name and the same number of parameters? Do you know that you are masking that method there? When you use the keyword new here, you are making clear that to Visual Studio that you know what you're doing and you want to redefine this method in the child's class. Okay? So again, it's not an error, it's just a warning.
Even though we don't use it, it's still the same.
It will result in the same. Actually, let me show this. Again, even though I'm not going to give the example right now of what is the difference, but keep this little table in mind. Actually, first of all, let's look at this. The new keywords, it breaks the relationship between the parent and the child. Again, this will be, what is this relationship? What is breaking that? Well, that will be more clear when I give you an example. But again, not going to do it today. I'm just going to, leave a cliffhanger for next class. So you come to next class just to see that. Overrides, you are keeping the link between the parent and the child. And again, you're going to see what this link is all about next class. But keep this table handy for you. If the parent is using the keyword virtual, the child can use the keyword override, and this is what will happen. And by the way, this is usually what you want to happen. So, virtual and override, we keep the link between the parent and the child, and as I said, usually this is what you want to happen. You can use virtual in the parents and new in the child. But that will break the link, will break this link, this mysterious link that exists between the two of them. That will not be explained today. And you can use virtual and no keyword, which is this example that I just provided. Sorry, not this example. This example is this one here. No keywords and new. Yeah. So you can use virtual and no keywords. This is the same as new, but Visual Studio shows a warning. Then we have a situation that the parent does not have a keyword like this one that we just went through. If the parent has no keywords and you try to override the child, you're going to have a compilation error. If the parent has no keywords and you redefine with new, you're going to break the link, and that's what we just saw. And if you have no keyword and no keywords, it behaves as new, but Visual Studio shows this little warning here. Just this. But again, because the example is very subtle, it's very, the difference is very minor. So sometimes it's hard to grasp that, and I want you to have a fresher mind at the beginning of next class to have a look at that. Okay? Okay. Aside from being curious about what is this link and why new, and again, being confused about new, and there's one more thing, actually. I didn't touch on base yet. So let's talk about base, the keyword base. So keyword base, remember that we had a keyword called this? This means that I'm accessing a method, a property from this object, okay? When I say base, I'll be accessing the property, the method, the field from the parent, okay? It works as a way to avoid conflict. In this case, if I say just get greeting, which get greeting will I be getting here? The one from its own class, from this class, the child class. But when I say base, get greeting, it will go to the parent. It will do whatever the parent is doing there. Michael?
So let's say that this is actually a grandchild.
Okay.
And then the parent did the same thing, and it had new get greeting, and it overwrote the greeting of the grandparent.
Yep.
Where does base go to?
Okay.
To the parent or all the way to the first?
So base goes to the immediate parent, and then if the immediate parent has its own implementation, it will run that. If it does not, it keeps going until it finds a real implementation, a true implementation there. So again, it keeps going up and up and up until it finds the definition. Again, if the parent has redefined it, it will run whatever the parent has. If it does not have any reference there, it keeps going to the one above it. It goes to the one above.
Even if the parent has redefined it, can you still access the grandparent method or not?
I get it. Yeah. I don't know. I really don't. Well, it's a good test that I can run. Yep. I'll make sure. I'll make a note of that. Okay, so again, base does that. It goes up to the parent to access its properties and methods. Okay? Yes?
Can we override static methods?
Yes. You really like static. Static.
I'm confused.
Yes.
This idea, because I think static is something in heap. So if there is already a method name,
No. Okay. So static means that it does not change from object to object. And I'll go back to one of the examples that we have worked a bit with that before. A bank account. I have my bank account number, you have your bank account number. However, so bank account number is not static, it's dynamic, it's non-static. However, the bank has a global interest rate, 9.9% for all customers. Okay, so interest rate is a good candidate to be static because it doesn't depend on my account, on your account. It's global. That's my attempt to clarify what static means.
and then we override it, then it becomes specific to the base group, the parent child class.
Correct. Yes. It will be just because it's static. The overriding mechanism doesn't change because it's static. Okay.
And can we override constructors?
Constructors. Okay. We can we can redefine constructor, yes. When we can still call the parent constructor. Again, we're going to talk about constructors a little bit later in this chapter, but a little bit later, not today. That's actually one of the next points that we're going to be touching, but not anymore today. Okay? Good? Who's ready to go home? Okay, so what I'm going to wrap with this. Again, make sure that you give it a try on those exercises, okay? Again, I'll be providing the solution and the videos for them. You don't have bonus to work on, so you just have that to work on for until next class. What else? Yeah, so just to recap, in 2 weeks we have, again, for the ones that were not here before, in 2 weeks we have our midterm, okay? The idea is that on the 20th we have exercise for the test, and then on the 21st we do the test. Open book, exercise based, there are no questions, you're not going to answer anything, it's not multiple choice, it's just exercise like the ones that you have been practicing. What else? Yeah, any questions? Anything? There are no questions. There will be exercises. It's just exercises. No questions. Can you imagine a test without questions? No, you don't have to answer anything. You just have to do code. Okay? Well, 1. We have 1 point A, 1 point B, 1 point C, 1 point D. Okay? Anyway, have a good weekend. That's it. I'll see you next week. Okay? Have a good one.